Hello, hello everyone. Welcome to the session on polyglotism in vRO 8.x. I'm Sajal Devnath. I'm a staff consulting architect with VMware. Before I start the presentation, please spare a few seconds to go through the disclaimer for the presentation. I'm part of VMware Professional Services Cloud Delivery Team, and I'm based out of Bellevue, Washington. Today, I'm going to talk about polyglotism, what it is, its relevance in software development, pros and cons of polyglotism, implementation of it in vRO, the core concepts and guidelines of polyglotism in vRO, and I'm going to end the session with a tip. So what is polyglotism? As per the definition, the usage of many languages is called polyglotism, and a person who has the ability to speak many languages is a polyglot. What is its relevance in software development? Traditionally, we have seen that an application was developed in a single language, whether it was C, C++, or Java, but it entirely consisted of a single language. But with the changes in the software development methodology, with agile development, DevOps, with the containerized applications and microservices, there's a shift in the way we develop application. Now we utilize multiple different languages to develop different parts of an application. So typically for front-end development, we use JavaScript or HTML, CSS, or PHP, whereas backend relies on Java, Python, Go, C, C++, or a mix and match of all of these. So that's how polyglotism in software development environment today is implemented. So what are the advantages and disadvantages of polyglotism? Let's look at the advantages first. So it simplifies the problem solving because a particular language is generally best suitable for developing something. For example, C or C++ is best suited for developing core applications, say device drivers. It's not very well suited to develop a front-end web page. You can do that, but then it's certainly not easy to do that. There are other languages which are more suited for that. So when you develop a holistic application, you can use different languages for building that part which is best suited to. So that's how it simplifies the problem solving. It provides the best performance. For example, the example that we just mentioned, C or C++ is probably best suited to build a device driver, but then PHP or JavaScript is best suited for front-end development. So in a single application, we can use these two different programming languages to build two different parts of that application, which will provide the best performance overall. That leads to the option that I can now have the best of all the worlds. So whichever part is I want to develop, whichever language is best suited for that part, I can utilize that language. I have the power to mix and match, which would lead to faster iterations, because now I won't have to worry about how to develop something using a language which is not perhaps best suited for that part. This should also improve the maintainability and ultimately increase the productivity. But at the same time, you have a hard time picking up the languages because you have too many choices now to develop an application. Which language will you use for a particular part? So that opens up the Pandora's box. So you have so many choices. It's like you have a hard time to picking one. The other problem is it's very hard to keep abreast of all the technologies. The technology field is changing at such a rapid pace. Today, something which is easier for something, developing a particular part, tomorrow there's a new technology. So it's really hard to catch up with all the technologies. The other problem is now, since you know so many languages, you become more like a mercenary. You know everything, but you're not an expert on any of the languages. So that becomes a problem. And the other thing is maintainability. Since you have multiple languages, multiple different codes in different languages, it's hard to maintain all of that. So that may be a problem or a few challenges for maintaining an application. Now, how it is implemented in vRO today? Traditionally, vRO was developed in JavaScript, so it's still the native JavaScript is native to vRO. On top of that, we have the option to utilize Node.js. The version is 12. Use Python 3.7, which is the native version included in vRO, or we can utilize PowerShell 6.2 or 7, based on whichever version that we want. It includes PowerShell 11 and 12 respectively. Now, if I look into the core concept, so we have the workflows and the actions. So I can write scripts inside a workflow, or I can write scripts in terms of in the form of an action. Now, action are independent entities. So if you're building or writing something which is pretty important, so I would still prefer to writing it in actions, because it's easier for me to maintain as a separate entity. I can update that particular action easily, and it does not impact anything else within that workflow. So if it's a small piece of code, you can include it directly in a workflow. Otherwise, if it's pretty significant, I would prefer writing actions for that particular task. Now, the other important aspect is when you write scripts using any one of the languages that I mentioned, you would have a handler function. So that's the entry point into that action or the script. It has two parts. One is context, the context in which that particular function is run, and the inputs that you provide. So you have the inputs which handles all the inputs that you provide for that script or action. And this becomes the entry handler. The other point is the name is important. It's typically handler.handler in that particular format. So if you want to change the name of your script, you need to change the entry handler as well. So instead of handler, if you want to say main or something else, you need to change that entry handler. Handler.handler it's expecting a file name called handler. Within that, there's a function that is called handler. So that's how it's expecting that I should start running the program from this particular point. So if you're changing any one of them, it's important to change that entry handler as well. The other important aspect is set the runtime limits. Typically for PowerShell running, the default memory limit that is given is pretty low. So sometimes you may see that you are trying to run a script which is written in PowerShell, but the task is failing because that's not enough memory. So while writing that script, change that memory limit. And this is another reason why you should utilize actions, because changing the memory limit that is not available today in workflows. If you write a script in workflow, you cannot change the memory limit. But then if you are defining an action, you can change the memory limit for that. So it's well suited for running a bit larger tasks which you are going to write in Python or PowerShell to change the memory limit for them. Also note the PowerCLI runtime that includes PowerShell, and the modules that is included in it are PowerCLI, vSphere PowerCLI, the PowerNSX, and PowerVRA. So if I'm interacting mainly with VMware environments, probably I would tend heavily towards PowerShell than Python because of the inbuilt functionalities that's there. So I can simply utilize one of those. And if I'm doing something else apart from that, probably I would tend towards Python or PowerShell, depending on your comfort with the language. In terms of demo, what I'm going to show is two demos. The first one is I'm going to just get the edge node details from an NSX manager. But I'm going to utilize three different scripts written in three different languages, native JavaScript, PowerShell, or Python, but all of them would do the same stuff. The second one, I'm going to create or delete a edge cluster profile in NSXT using the REST API. But in the single workflow, I was utilize different scripting language as part of that particular workflow to achieve the end goal. So let's go ahead and have a look at the demo. So this is my vRelease orchestrator environment. And the workflows that I have is this. First of all, get edge node details using native JavaScript. Now, what I did is I defined a REST API endpoint. So if I go to my inventory, I can see that I have defined an REST API endpoint, NSX manager, pointed it towards the NSX manager. And I have defined a get task. I provided the URL template and all the authentication details. So this is a REST operation that is attached to the HTTP REST endpoint. And I'm simply going to run this REST task, REST operation. So that's what the native JavaScript provides me the option with. The other two are simple script, the PowerShell script, where I am defining the REST API calls. I'm taking the NSX manager and I'm simply reaching out to it using the REST API and getting the information. For Python, again, this is a simple script which is reaching out to the REST API, to the NSX manager using the REST APIs, using the same calls, transport nodes, and getting the information. So let's run the scripts. And for the simplicity, I have simply hard-coded every other information. I could have taken as inputs the user ID and passwords as inputs as well. So I have run this script and I got the information. Now, if I look at the performance, I see it's 253 milliseconds. It took all of that time to run this script. Now, if I run this in PowerShell, using PowerShell, I'm going to get the same information, but it's going to be a bit longer because it's not native. So note this, when you are utilizing the inherent JavaScript is still faster. The PowerShell or Python, it needs to load all that environment and then run it. So it took 6 seconds for run that in PowerShell. And in Python, if I run the same information, so I'm getting the same information, but just using different programming languages. So this is Python. It ran faster, so it took 1.5 seconds. But still, the native way is much faster than anything else. So here you note that I have written the script directly in the workflow. No action, just handler function. It has context and inputs. As inputs, I can take any variable as inputs, but then this is how it's working. Now I have create edge cluster profile. On the right-hand side, I have the NSX manager open. There is no edge cluster profile right now. So I want to create an edge cluster. But for this, if you look into this, I am utilizing two actions. One is written in Python. This is a simple script to do a comparison to a check whether the edge profile is already existing or not. And then I am creating the edge cluster. This is written in PowerShell. Let's have a look at the actions. So I define the actions. And here I see create edge cluster profile. So this is the PowerShell script to create the edge cluster. Similar functionality, similar scripting, same function, handler function. It has context and inputs. and then I have an output if I want. But then here you see the memory limit option. I needed to increase the memory limit, otherwise it would give me memory fault. So I'm just creating the edge cluster, but get edge cluster profile. Actually, I have the same tasks written in PowerShell. I could use any one of them. I can use either PowerShell, or I have the same task written in Python. But in this case, I have something else. So in the workflow, you have seen that I can write a direct Python script inside the workflow. But here's that's another way of writing writing scripts. Now, Python scripts, you see that I import certain modules. The environment that comes, and this is true for any one of them, either PowerShell or Python. The inherent environment that I have, it gives me certain modules. What if I need more modules which is not pre-built there? So for this, actually, for this PowerShell script, I had this requests and then URL lib3 modules required, which is not part of the default installation. So what I did, or what you need to do, is create a folder. Simply create a folder, go inside that folder, create a directory called lib, and then use pip command to install the needed dependencies. So I installed URL lib3. So pip install URL lib3, target is lib directory. It installed all the dependencies, URL lib3 and the requests and anything else that I needed. So it installed all of that. I created one Python file, handler.py. So remember that the entry handler was handler.handler. So this is expecting a file named handler. If I named it as main.py, so I would say main.handler. Within that, I have this handler function. So if I have multiple functions, I would still mention that which function that it start executing with. So that's the reason it's very important to check the name and the function that you want to start with inside the name, and then change that within here. So you change the entry handler. Once you have the script and the library functions or the modules ready, zip it up in a zip file, and then simply upload the zip. So in short, if I want to define a new action, say test, and then in terms of script, when I say Python, it gives me an option of writing the script directly here, or upload a zip file, which would say have this. And then I can change the entry handler. Say, if, for example, if my file name was main and inside that was, say, entry function, so I would say main.entry, and then it would expect that when they unzips the particular folder or particular zip package, it would expect a file called main.py, and within that a function as entry as entry, named entry. And then you change the memory limits, define the inputs. Whatever inputs that you would mention here, you can utilize as input function or input variables within the handler function. So that's how you define an action, another way of defining an action. So let's go ahead and see how that workflow. And then when I created that create edge cluster profile, I imported that action, which is written in Python. So this word is written in Python. This is just plain checking, and then this is create edge cluster, which is written in PowerShell. So let's run that. Give it a name as test1, profile description as test1, and then run that. It's going to show me the information that what it's doing, and it's completed. So let's come back here in NSXT, and I can see that it's created an edge cluster profile named test1. Now, again, the same thing. Since I have written this scripts, I can run the same script and then say, give it a name as again test1, which should fail because there is another profile which pre-exists, so it failed here. The Python script that I had written had the check functionality, where it gets the list of the edge cluster profiles, and then it throws an error. So now for deletion, I have the get edge cluster profile, the same function that was written in Python, but for deleting, I'm using the native REST API calls, native JavaScript calls, which is this. So this is the native JavaScript, which is actually calling out a REST operation defined on the HTTP REST endpoint. So this is what I'm going to run. And the display name is test1. That's what I want to delete. And once it completes, the task should be the edge cluster profile is deleted from here. So that's how you would use polyglotism as per your comfort level, which are it's more towards the task that you want to do. As I mentioned, that PowerShell that it comes with the vRO package, it includes PowerCLI. That means vSphere PowerCLI, PowerNSX, and PowerVRE. So if you are interacting with those endpoints, it's easier to use PowerShell than Python. Python also poses a bit of challenge because it depends on a lot of external modules, and the modules are not there. So each time you want to utilize one module which is not there, you will have to write this script outside of vRO, import the modules, install the modules, and then upload the zip package in actions. So that sometimes creates problem writing Python scripts. So in that aspect, PowerShell is better because by default, it gives you a lot of modules. But Python also makes certain tasks really easy. So depending on what you want to do, you can utilize scripts entirely based on PowerShell or Python, or you can do a mix and match where you can utilize multiple components. So this is exactly, you would utilize all of these functionalities in a various orchestrator. At the end, I would say the documentation for vRO polyglotism is really good. You need to go ahead and check the documentation in the VMware official documentation site, and check for the examples that is given there. So please take your survey. That would help me and every one of us improve the session for in future. Thank you so much for your time. Have a nice rest of the day.